We had a GoFormative question in Wednesday's lecture that used a heating curve. And so this is the general appearance of a heating curve. And we had talked about there being 5 segments to the heating curve, and that each individual segment or leg of the heating curve has its own separate calculation, and that the sloped areas of the heating curve use the QMCAT equation, and the plateaus, those are the phase changes. Since there's no temperature change in the plateaus, it needs a different formula, and that was quantity times the delta H of either melting or vaporization. So anyway, the question we had in GoFormative, and these are kind of tricky to do until you've done a couple for practice or a few for practice, but this question asked to calculate the total energy required to raise the temperature of 25 grams of snow, which is just basically frozen water, starting at minus 35 degrees Celsius all the way up to 65. Now, not every problem like this is going to have you do 5 separate calculations, especially on an exam. It's tedious, it takes a long time, and so you have to get comfortable with doing problems that might have 2 or 3 steps and not all 5 of them. So the first thing you want to do is kind of sketch out a heating curve and make little marks where you're beginning. And so in this case, we're beginning at minus 35. So I'm going to make a little note, call that minus 35. And we know that the melting point of water is 0, right? So we know that 0 is there. We know the boiling point of water is 100. So you have to know the melting point and boiling point to be able to understand the curves. It won't always be water. And so this question asks us to heat it up to 65. So we're not going all the way up here to steam. We're like maybe here. So we'll call that 65. Okay, so let me change colors of my pen again. Okay, so how many calculations do we need? Well, we have to do step 1, right? So we've got to heat it from minus 35 degrees C to the melting point of water, which is 0 degrees C. And so that's a sloped area, right? So that's going to use QMCAT. And then step 2, we have to melt it all. And during any phase change on any plateau, that is going to use the amount times the delta H value, which is a constant you must be given. You'll always be given the specific heat capacities and the delta H values. And then we have to do the third calculation, but only part way, right? So the third calculation is going to be taking it from 0 degrees once it's all melted up to 65 degrees, okay? So that we're going to do 3 calculations, and that's a temperature change, a sloped area, so that's going to be the MCAT. So there's going to be 3 separate calculations. Be very, very careful that the units are the same, and at the end we're going to add 1 plus 2 plus 3 together to get the final answer. So I'm going to start with a fresh page and walk through each of those 3 calculations. All right, so calculation 1. That was the sloped area. All right, so the heat involved in heating it from minus 35 to 0. So the mass is 25 grams. The specific heat capacity of frozen water, that's the snow to begin with, is 2.09. And the temperature change is, it's out, okay, so hold on. Temperature change is always final minus initial. So the final is 0 degrees, right? And the initial was minus 35. All right, so if you punch all that into your calculator, you get 1,800, and I'm going to round right there, joules. All right, So that's the energy required for step 1. Step 2 is to melt it, and for the plateaus you're going to use M is quantity, times, and melting is called delta H of fusion. And so if you look up the delta H of fusion that was given in this problem, it is 6.02, but the units, pay very close attention to the units here, are kilojoules per mole. Now sometimes delta H fusion will be given in kilojoules per gram, sometimes it'll be joules per gram, so it's kind of tricky, so just pay close attention. Now, since it's given in joules per mole, this M has to be moles so that the units cancel. And we have grams of water, remember, not moles. So we've got to take a minute and we need to calculate how many moles of water. So 25 grams, and of course to convert from grams to moles, you need the molar mass of the substance and the molar mass of water, right, H2O, is 18.02 grams per mole. Okay, and so the moles that we have, 1.387 moles of water. So let's go and put that here. Okay, one of my dogs is snoring. I don't know if you can hear it, but it's not me. All right, so moles cancel. And then, so Q for melting these 25 grams is 8.352 kilojoules. Now remember, the delta H value is given kilojoules, and for step 1, it was in joules. So before you add these together, they've got to have the same unit. So I'm going to go ahead and convert right now to joules. Okay, so these metric conversions are something that you need to have committed to memory. That's not something I'm going to give you on the test. And so, it's one of the first few slides in the very first PowerPoint we went over is a list of common metric conversions that you'll want to either print that down or copy it down, and maybe on note cards or something, and just kind of start going through and getting yourself committing them to memory. And so so Q in joules, that's a snore of another one of my dogs. Oh my gosh, I'm doing this at night. So, okay, so here's the heat for step 2. We have one more step, and that is using QMCAT. It's a sloped area of the curve, and that is taking it from the melting point of 0 degrees up to 65 degrees. So let's go ahead and plug in that. Mass, again, is 25 grams. Specific heat capacity of liquid water is 4.18, and the units are joules. You can go back and check it if you want. And then the final temperature is 65. And the initial temperature for this portion of the curve was at the melting point, 0. And so if you plug all that in, you get the Q is 6,793 joules. All right, so let me go to another blank page here. I'm just going to add these 3 together. Step 1, step 2, step 3, they're all in joules. Alrighty, so let's see. So then the final total total heat required, and that's it. Okay, so there is a worksheet in week 1 folder in D2L in the content section. So you definitely want to start practicing these, okay? That's it.